Alright, continuing with functions, we're going to talk about recursive functions now. So, what these are known for, they're known for their top-down approach to problem solving. Recursive functions basically break down a problem into more subproblems and then solves them. So, what recursive basically means is that a function calling itself. So, it uses itself over and over again. And what we need in these is a base case and a recursive call. And I'm going to, right now, I'm going to just define a function, a recursive function, so you can actually see how it works. So let's do this. So it's going to be for factorials. So this will demonstrate how to calculate a factorial with the help of a recursive function. So let's say we have our argument or parameter called n, and first we need the base case, which is if n equals 1, then we return value 1, which helps us exit the recursion going on. Return 1. Else we're gonna do return n equals factorial. Oh, and wait, no, there shouldn't be equal sign there. That was my mistake. N times factorial n minus 1. So as you can see, based on this code, if n isn't 1, it's going to do this return statement multiple times. So it's going to do n times function itself over and over again. So this basically divides the calculations into subproblems. So let's actually demonstrate this right now. So let's call our function. So let's say print factorial. Let's say we're going to do the factorial of, I don't know, let's give us a number. Let's say the factorial of 5. And then we're going to build that. And I made a mistake. I should have wrote, let me just see here, forgot the colon again. And as you can see, 120, which is correct. So as you can see here, it just does what it says. The factorial does 1 times, it goes from 1 to times 2, actually goes from 5, 4, 3, 2, and all the way to 1, which then finishes. So it does 5 times 4 times 3 times 1. And that's basically how factorials work, as you probably already know. So let's actually look at other kinds of, there's actually a couple types of recursion. We have regular recursion, and we also have tail recursion. So let's first demonstrate regular recursion. So def sum, this function is called sum now with the parameter n, with colon, of course. All right, so if n equals 1, we're going to, as before, return 1. And then else, let's see, we're going to do like before in the factorial problem, return n plus sum n minus 1. So we're doing, for example, if it was 5, we do 5 plus 4 plus 3 plus 2 plus 1. And this is basically regular recursion. And tail conversion, for example, we're going to do tail sum now, tail underscore sum parameter. What this does, you're going to see in the it's going to do the following. So we'll have the following parameters. N, this one's going to be called accumulator equals the default value is 0. So inside this function, if n equals 0, we're going to return the accumulator, and then else, then we're going to return, if it's not 0, we're going to return, you're going to use recursion here, function within the same function within itself, n minus 1, with arguments in accumulator plus n. So let's just build and check everything's okay. So everything's good. All right, now let's print them. Print sum, and with the argument 10, and then print tail sum with the argument same as 10. So 19, 10. All right, print. As you can see here, why did it give me none? So let me just check my code. Accumulator. So here we go, sum. So here, as you can see, sum is a predefined function. Now I'm just checking why it gave me none. Let me just check my code again. If equals 0, accumulator. That should be good. Yes. All right. So, oh, of course, the indentation, I believe, and something else. Oh, the return should be. No. Oh, right. Silly me. I forgot to return on the other part of this statement. Silly me. As you can see, we got the same result. So sorry for the delay. I just kind of had a sort of brain fart. So what we did here is basically we did the same thing but in two different ways. The first way is just regular recursion, and the second way we had tail recursion, where we actually used a repeating parameter, as you see here with this accumulator. And so that pretty much, I hope you kind of got the concept of recursion through these examples. We hope you tune in next time.